Hello, hi everyone. How are you all? Am I audible to you? Hello everyone. Please turn on your cameras. Hello, Madiha, Rohika, Arna, Afan, Ibrahim, Vaishnav. Please turn on your cameras. Okay, so let us begin, everyone. Please turn on your cameras. Afan, Ibrahim, Bilal, Vaishnav, Rohika. Come on, guys, please. Yes. Hello, Rohika. How are you?
Fine, sir.
That's nice. What about the rest? Please turn on your cameras. Come on. We'll not be able to start everyone until and unless you turn on your cameras. Madiha, please turn on your camera. Afan. So how is the practice going, Rohika? How is the prep going?
Fine, sir. The second book is a little on the weaker side. I think I'm okay with the first book.
Okay, nice. So yeah. Everyone else, Bilal, Afan, Ibrahim, please turn on your cameras. Madiha, turn on your cameras. Come on, everyone. Come on, everyone. As soon as you will start turning on your cameras, we can start. Please, cameras, everyone. Or send me a reason if you are not able to turn on your cameras. Send me a reason in the chat box so that I can forward it to the support team. Come on. Hello, Ibrahim. How are you?
Fine, sir.
Fine. Which batch are you in? 1201, 1202, or you are in offline batch?
4-2.
02. Nice. So just 1 second, I'll be back. Okay. Rest of you, Rohit, please turn on your camera. Hadia, please turn on your camera. Or is it Sadat? Please turn on your cameras. Come on, everyone. So how is the prep going, Ibrahim? All well?
Yes, sir.
So 100 out of 100 in CBSE? Is that going to happen?
No, sir.
No, why not? Acha, in JEE, what will happen? In JEE, how many marks do you think you'll get?
JEE first shift went a bit bad for him.
Okay. So have you calculated? Have you checked the memory-based solutions?
No, sir.
No, you have not analyzed. Okay. No worries. Rohit, please turn on your camera. Vaishnav, camera. Hadia, please turn on your camera. Afan, cameras. You have 3 minutes, Afan and Bilal. Otherwise, I will, put you in the waiting room. Okay. So let us begin, everyone. Okay, so today what we are going to do is, everyone, we are going to revise vectors. Okay, so we are going to start revising vectors and 3D, three-dimensional geometry as well, with the first thing, that is direction cosines. Okay, but before we move on to direction cosines, just remember the vector. Okay, that is used to represent a particular point in a three-dimensional space is known as what, everyone? Is known as the position vector, right? So the direction or the position, okay, that is used, okay, to represent a point on a three-dimensional plane, okay, is known as the position vector of a point. Okay, so let's say this is point P, okay, with direction ratios A, B, and C. Okay, this is what, everyone, the value of X, Y, and Z of a particular point, okay, in this particular thing is known as what? Direction ratio. So A, B, and C are my direction ratios. So that means what, everyone? That means according to this picture, this diagram, this is going to be A, right? This is going to be B, right? And this part is going to be C, right, everyone? Yes. And the angle that it is making, this angle that it is making is the angle alpha. This angle is going to be what? Beta. And this angle with the z-axis, let it be gamma. Is this clear, everyone? Tell me yes or no. Any doubts till this point? Yes. So a position vector is making what? Is making angles with all the axes, with the x-axis, with the y-axis, and the z-axis. That is alpha, beta, gamma, respectively. I hope this makes sense to each and every one of you. Yes. So now, everyone, if I take this triangle out of this figure, that is OAP, this triangle out of this figure, that is OAP. I've taken this out, everyone, as you all can see, right? So this angle is nothing but alpha. Okay, this is a 90-degree angle. Angle A is the 90-degree angle, as you can all see. So basically, my cos alpha is going to be what, everyone? Is going to be the ratio of A upon R, right? Are you getting my point? Yes. R is what? R is nothing but the magnitude of my position vector OP, everyone, right? It is the magnitude of my position vector OP, right? And A is my direction cosine, everyone. So similarly, if I do it for all the other angles, cos alpha, cos beta, and cos gamma, they are known as what, everyone? They are known as direction cosines, if you all remember this, okay? Very important thing. There will be a lot of questions that is going to come in this particular, from this particular concept, okay? So it is going to be A by magnitude of OP, right? Now, what is the magnitude of a position vector? That is nothing but what? So the direction ratios are A, B, and C. So the magnitude of OP position vector is going to be root of A square plus B square plus C square, right? So over here, we will write root of A square plus B square plus C square. Okay. Now, it's not just A, it's plus minus. Okay. Similarly, we will have plus minus B, the value of Y, plus minus B upon the magnitude of the position vector, A square, B square plus C square, right? And similarly, cos gamma is going to be what, everyone? The value of Z, or the direction ratio of Z, that is going to be C upon root of A square plus B square plus C square. I hope this makes sense to each and every one of you, right? This is what you must have all learned in the previous classes, right? This is just a recap, everyone. So I'm not going to go in detail how the direction cosines are the way they are, okay? I'm just going to give you a quick reminder of all of these things. I hope this makes sense to everyone, right? So we have a short form of how we represent these direction cosines, that is L, M, and N, right, everyone? Yes. I hope you remember this, okay? So these are my direction cosines, everyone. L, M, and N, okay? DCs, right? And what are these, everyone? These A, B, and C. These are my direction ratios, right? I hope this is pretty much clear to all of you. Yes, okay? Yes, moving on, everyone. Now, the very important thing that we need to remember about direction cosines is what? That the square of L plus the square of M plus the square of N is equals to 1. This particular equality will also be used in solving many questions. Okay, so very important, everyone. Today, I'm going to just revise concepts which you are going to use in your questions. No other concept, no useless concept I'm going to be discussing. So these notes are going to help you a lot. Do not make notes during the class, just make it after the class. I'll send it to you, okay? I'll share the link to this OneNote notebook with you all, okay? Don't worry about it. Yes, please turn on your cameras, everyone. Bilal, Vaishnav, Jasim, Mehek, Nishad, please turn on your cameras. Come on, everyone. Yes. So that is about it, everyone. That is about direction cosines. Okay. Now we will discuss about vector joining 2 points, everyone. What is a vector joining 2 points? Okay. Now let's say, for example, I have 2 points on the 3-dimensional space A and B. Right, everyone? Yes. Now these points A and B are connected with what, everyone? They are connected with a line, right? Yes. Now these points A and B might have some position vector, right, everyone? Yes. So let's connect them to the origin, right? So let's say this is origin, everyone, and the position vector of A is A vector, and the position vector of point B is B vector, right, everyone? Yes, makes sense to all of you. Yes, and I hope you remember the triangular law of vector addition. Yes, right, everyone? So using that triangular law, what can we do? Okay, we can say that A vector plus AB vector, okay, is equals to what? Is equals to the B vector, right? I hope this is clear to you, everyone. So I'll transpose A to the other side. I will get AB vector, which is equals to B vector minus A vector, right, everyone? So over here, what is going to happen, everyone? Over here, we can observe that B vector is nothing but the position vector of the point B. So basically, position vector of point B minus position vector of point A, okay, of B and point A, right? So that is how we find the AB vector. That is the vector joining 2 points, everyone. I hope this is clear to you all. Please tell me yes or no. Everyone, any doubts till this point? Now, moving forward, everyone, what we are going to do is further on, we are going to identify how do we write it in a better form. Okay, so see, let's imagine this point B is nothing but x2, y2, z2, right? And this point A, oops, just a second, this point A, let it be x1, y1, and z1, right? Is this clear, everyone? So my AB vector is going to look like how? It is going to be nothing but x2 I cap plus y2 j cap plus z2 k cap minus x1 I cap plus y1 j cap plus z1 k cap, right, everyone? So that is going to be x2 minus x1 I cap, right, plus y2 minus y1 k cap j cap, right, and z2 minus z1 k cap. Right? That is what we have already learned, right? This is just a revision, everyone. And what is going to be the magnitude of this vector? The magnitude is going to be nothing but x2 minus x1 whole square, right? Plus y2 minus y1 whole square, plus z2 minus z1 whole square, right? That is what we already know, right? So these are a few things that we had to remember, right? And we have done that. Now, the important thing, another important thing is what, everyone? The section formula. I have some problem from my camera. Clear, sir. Okay. Yes. So section formula, everyone. What is the section formula? Now, over here, what's happening is, everyone, there, if you will observe, you'll find some things out. Okay. This is origin, right? Yes. And this is my PQ, right? This is my PQ vector, right? Now I have to find out a vector, position vector for this point R, okay, which is dividing my PQ vector in the ratio m is to n, right? How will I do this? Very simple. So R vector is going to be equals to what, everyone? Is going to be equals to, now opposite, okay? So m will be multiplied with P, okay, and A will be multiplied with N. I hope this makes sense to all of you. Yes, remember that, everyone. Opposite, okay? Is this clear? So that is going to be n times p vector plus m times a vector upon m plus n, right? Now, you will say, sir, how do we do this? Simple, everyone. Nothing difficult over here. You are dividing what? Dividing this PQ vector in a ratio m is to n, right? So that means PR upon RQ vector is equals to m upon n. Now, once you try to solve this up, everyone, you will be able to easily get to this particular formula. Very easily you will be able to do so. So what is R vector? Now, position vector of point R, position vector of point R is R vector, right? So R minus what? Position vector of P, right? Position vector of P is A. So R minus A, right? Yes. And then RQ vector. What is RQ vector? Very simple, everyone. Position vector of Q, that is going to be how much? B vector, right? Minus the position vector of R, that is R vector, right? Which is equals to M upon N. Now, once you simplify it, cross multiply it, everyone, okay? Transpose it, okay? So you will get this original formula in hand. Same thing will go over here, right? Just a second, let me shift it sideways. Yeah. So this is R vector, everyone. Similarly, we are going to find the position vector R. Now, the division is external, everyone. The division is what? The division is external. Okay. So basically what we will have, you will have R vector. Okay. M n times P vector minus M times A vector upon M minus N. I hope this is pretty much clear to you all. Yes. MB. Okay. Minus NA. That is correct. Okay. Now, scalar product, everyone. Now, I hope you all remember scalar product. A dot B is equals to the magnitude of A times the magnitude of B times cos theta. You must have learned this, in physics as well. You have been learning this from quite a long time, right, everyone? Yes. Now, let's say, for example, A vector is given to you as, let's say, x1 I cap plus y1 j cap plus z1 k cap, right? And B vector is given to you as x2 I cap plus y2 j cap plus z2 k cap. So A dot B can also be written in this particular format or found out in this particular format where we multiply the direction ratios of the corresponding component of my vector. Okay, so x1 and x2 will be multiplied, y1 and y2 will be multiplied, and z1 and z2 will be multiplied. I hope this is pretty much clear to you all. Any doubts till this point? Let me know, everyone. Great. Now, what we are going to do is, everyone, we are going to discuss. Yes. Now we are going to discuss some properties of scalar product or the dot product. Okay. Properties. Some important properties, everyone. Okay. Which are going to be used in your solving questions. Okay. So the first important property, that is dot product, is what, everyone, is commutative in nature. That is A dot B is equals to B dot A. God, just a second, everyone. I think I'll have to reload my screen. Okay. Yes. So A dot B, okay, that is going to be B dot A. Okay. Now, the second thing, that is if A vector and B vector are orthogonal vectors, okay, or let's say they are perpendicular vectors. In that particular case, what will happen, Rohit? A and B are orthogonal. Rohit, are you there? In that particular case, dot product is what? Is 0, right? Rohit, please pay attention in the class. Okay. Third, now we know that if A and B are orthogonal, A dot B is equals to be 0, everyone. Now I know my I cap and j cap are two such vectors which are perpendicular in nature, right? Unit vectors that are perpendicular in nature, everyone, right? It is a unit vector of x-axis, unit vector of y-axis, right? So they must be perpendicular to each other. Now we know that perpendicular vectors or orthogonal vectors, they are always 0. So I dot j, j dot k, right? Yes, and I dot k is equals to 0. That is, it's a null vector. I hope it is pretty much clear to you all. J dot I is also going to be it, right? J dot I is also going to be 0, right? K dot j is also going to be 0. K dot I is also going to be 0, right? Yes, everyone. Third important property, everyone. Yes, if A vector and B vector are parallel, okay, in that particular case, what is going to happen? So no, just think about it this way. No, just let's write it in a different property. A dot A, that is going to be magnitude of A time whole square, right? Then this implies what? Now there is a sub property of this property, everyone, that is going to be I dot I, that is going to be equal to J dot J, right? Is going to be equals to K dot K. I know the magnitude of my I, J and K are what? That is 1, right? So that is equals to 1 square. So that is equals to 1, right? I hope this is pretty much clear to you all. Please tell me yes or no. Last property, everyone, last important property, that is the projection of A vector on B vector. That is going to be A cos theta if the angle between A and B is theta. Clear, everyone? Okay, so important properties of dot product. Right now, what we are going to do is, everyone, we are going to discuss some important properties of the vector product. Yes, now what are the important properties of vector product, everyone? Let's revise first. Let's remind ourselves what's a vector product. Now the vector product, everyone, is A cross B, right? Is equals to the magnitude of A, right, times magnitude of B times sine theta times n cap, right? Now the cross product or the vector product between two vectors is always going to be vector in nature, everyone. Okay. So this quantity that we have got is a vector itself, but the previous quantity is a scalar quantity. Is this clear? A dot B dot product does not have any direction, but vector product does have a direction, right? And this direction, everyone, is what? It is perpendicular to both the vectors A and B. So let me, help you visualize this thing, right? Let me help you remind how did we used to visualize this thing. So that is A vector, that is B vector, right? That's the angle between them is theta, right? So that is what, everyone. That is n cap, everyone. Now n cap is what? N cap is the unit vector that is in direction, that is perpendicular to both A vector and B vector, right? Yes, so it is perpendicular to both. Okay, so this is n cap, and the one that is in the reverse direction is going to be minus n cap, right? And I will find my A cross B over here. So this is going to be my minus A cross B, and this is going to be my plus A cross B. Is this clear, everyone? Just reminding you all. Okay. Yes, it's a vector, everyone. Please, this quantity has a direction. Okay. The resultant will be a vector, not a scalar. Okay. It will have magnitude and directions both. I hope this makes sense to you. So same thing, everyone. Let's say, for example, there are two vectors A and B. Okay. And I'm taking a vector product on them. Okay. So it is going to look like how? So A cross B, everyone, is equals to what? The determinant of I cap, J cap, K cap. I'm not telling you why is it the way that it is, because I've already told that to you in the class itself, right? And we do not have time. This class is a revision class, one shot class of 2 chapters, right? So that is going to be X1, Y1, Z1, X2, Y2, Z2. I hope it is clear to you all. Please tell me any doubts till this point. Now, moving forward, everyone, again, we are going to discuss some properties of the vector product, everyone. What are the properties of vector product? Properties of vector product. Okay, very important. Now, the first important property is that this particular product, that is the vector product, does not satisfy what? It does not satisfy commutative property, right? So it is not going to be equal, but it is equals to minus B cross A. Okay. Is this clear, everyone? Tell me yes or no. Any doubts till this point? Now, everyone, if A and B are parallel to each other, okay, if A vector and B vector both are parallel to each other, in that particular case, the sine, that is the angle between both of these angle, is going to be 0. So AB sine 0, that is going to give you the resultant, that is 0. So this will be a 0 vector, a null vector. Okay. Third point, everyone. Observe. Let's say, for example, the vectors are orthogonal in nature, that is, they are perpendicular to each other. So the cross product between them is going to be what, everyone? It is going to be A into B, right? Magnitude of A into magnitude of B. Okay, everyone. Is this clear? Tell me yes or no. Yes. Then now, if you think about it, everyone, over here, both of my vectors are parallel to each other, right? Yes. So if I take I cap and do a cross product of it with I cap, which will be equals to cross product of J cap with J cap will be equals to cross product of K cap with K cap. That is going to be a null vector itself. Are you getting my point, all of you? Please tell me yes or no. Yes. Now over here, what is going to happen, everyone? Over here, let's say I have I cap cross J cap. It is going to be equals to what, everyone? J cap cross K cap. Okay. Is going to be equals to what, everyone? It is going to be equals to K cap. No, not equal. So sorry. I cross j is going to be k, right? Yes, j cross k is going to be I, right? Yes, and k cross I is going to be j. I hope this is pretty much clear to you all. Huh? Now, but if we go in the opposite direction, we know that everyone, I cross j is k, so j cross I will be what? I told you all. I told you a cross b is equal to minus of b cross a. So that is going to be minus k cap, right? Yes. And then k cross j is going to be what, everyone? That is going to be minus I cap. Okay. And I cross k is going to be minus j cap, right? Yes, everyone. Now, there is an easy way to represent this, and remember this, I, j, k. So if you go from I to j, everyone, okay, you will get k, right? A positive k. If you go clockwise, right? If you go from j to k, j cross k will give you positive I. Are you getting my point, everyone? K cross I will give you a positive j, right? But if you go anti-clockwise, j cross I, you will get a negative k. If you go, let's say, for example, I cross k, that will give you a negative j, right? K cross j, that is going to give you a negative I. I hope it is understandable to you all. Yes, clockwise positive, anti-clockwise negative, right? Then some more important properties, everyone. Yes, just a second. Yes. Let's say you have a triangle, everyone. Yes, and the adjacent sides of the triangle is a cross b. Sorry, a and b vector. Okay, you can represent them using a and b vector, right? Yes, everyone. Yes. So that is going to give you what, everyone? So you can calculate the area of triangle OAB using what? Using half a, but basically the vector product half of magnitude of a cross b, right? Any two adjacent sides. Okay. The reason is very simple, everyone. The reason is that cross product will always give me a particular vector that will be perpendicular to both of these, right, everyone? So that is why. And you remember half into base into height. Remember that, everyone. So basically it will be what? A sine theta, right? Yes, and a sine theta will be what, everyone? A sine theta will be my height and this is my base. So a b sine theta. Are you getting my point, all of you? Tell me yes or no. Area of quadrilateral. Area of quadrilateral. Area of quadrilateral, let's say OABC, right? So that is going to be half, no, not half. It is just A cross B, right? Okay, everyone. So let me remind you, okay, how is this going to work? Now we know that, let's say, for example, this is a parallelogram. Okay, we know that the area we calculate by base into height, right? So this is base and this is, let's say, my A vector. Let's say this is my B vector, right? This will be, H will be my A sine theta, right? So A sine theta into B, that is going to give me what, everyone? That is going to give me my height, that is height into base, and that is how I will get to the area of this particular parallelogram, right? Is this clear, all of you? Tell me yes or no. So these are some properties of vector product, everyone. Yes, I hope it is clear. Rohika, you want to write this down? Don't worry, I'll share notes with you. Okay. Now, very important, everyone, vector and Cartesian equation of a line through a point parallel to a vector, right? Vector and Cartesian equation of a line passing through a point and parallel to a vector itself. So over here, if you will observe this image, everyone, what is this? This particular point A is, now think about it. Acha, chalo, let me tell you one particular thing, right? How many lines can you pass through one point, everyone? How many lines can you pass through one point? You can pass infinite lines through one point. Yes. But let's say I give you a point and I tell you that the slope of that particular line, I give you a point and a slope, right? I give you the point and a slope. Then you will have only one unique line, row, everyone. Tell me, right? If you know the slope of a slope for a line and the point, then you will have only one unique line. Because if you draw any other line through this point, the slope will be different of this line, right? Yes. So that is the thing, everyone. We can draw a unique line through a point Okay. And when it is parallel to a vector, because if it is parallel to a vector, it will give me what, everyone? It is going to give me what, everyone? It is going to give me the slope, and at point 2 I need, right? So this is what is important, everyone. So over here, it is passing through the point A, and this is my B vector, everyone. I hope it is making sense to all of you. Yes. So now, everyone, what is going to happen if you will observe this point P is what? This point P is any point on this particular line, right? Any point on this particular line. So point P is representing any point on this particular line. So R vector is what, everyone? R vector is representing any general point. It is a position vector. R vector is a position vector, is a general position vector for any point on this line, right? It's a general position vector for any point on this line. Okay, everyone, is this making sense to you all? Now, if you remember the triangular law, what will you have? You will observe what? AP vector, right? Yes, or basically let's write it in a better form. That is going to be now let's imagine this AP vector. Now AP vector will be what, everyone? AP vector will be lambda times B vector, right? Why? Because this is my AP vector, everyone. Yes, and it is parallel to the B vector, right? Yes, so I can write it as lambda times B vector, right? Yes, and this is going to be what, everyone? This is going to be OA, and this is going to be OP, right? So now, everyone, what is going to happen using the triangular law? We know that A vector plus AP vector, right, is equals to what? Is equals to R vector, right? Yes, now I know A vector plus AP is what? Lambda times B vector, so is equals to R vector. Are you getting my point, everyone? Tell me yes or no. Any doubts till this point? Now, R vector is what, everyone? R vector is representing any general point on this line. Okay. So R vector is xi cap. Okay. Plus yj cap plus zk cap. Right. Okay. Yes. Remember that. A vector is the position, is the point, right? So let the point be what? Point could be anything, everyone. Let's say it is x1 I cap plus y1 j cap plus z1 k cap, right? Because see, everyone, what did I need? I needed a point. Let that point be A, right? x1, y1, z1. And parallel to a vector, let that be B vector, okay? Right? Because that gives me the slope. Okay, B vector could be anything. B vector, let B vector be equals to, equals to A vector, sorry, AI cap, right? Plus BJ cap plus CK cap. Is this clear, everyone? Tell me yes or no. Any doubts till this point? So that is how we get the Cartesian equation of a line, everyone. What is my Cartesian equation of a line? This is my Cartesian equation of a line. Just a second. Let me push R to the other side like this. Don't worry, we will do questions as well, right? It's important that we revise as well, because otherwise you will not revise on your own the concept. And if concept is fresh in your brain, you can solve any question in the world, right? So now, everyone, observe. What is this? This is my vector equation of a line where R stands for this, A stands for this, and B stands for this, right? Now, if I have to calculate, let's say, for example, the vector equation of a, so the Cartesian. Now, this is my vector equation, everyone. This is my vector equation, right? Vector equation. Let's say I want to calculate the Cartesian equation of a line. How will I do that? Very simple, everyone. I know that my R vector. Now see, why am I doing what I am doing? Why am I deriving the Cartesian equation from the vector equation? Because you might need to turn the vector equation into Cartesian equation or Cartesian equation into vector equation. Okay, I do not know how much you all know. Okay, so that's why I'm just, just for the sake, it is going to be a good refreshment for you all. I'm doing so. Okay, if you know, well and good. Okay, well and good. So now, everyone, so instead of R vector, I will put this. Okay, that is xi cap plus yj cap plus zk cap. Okay, yes, and instead of my A, that is going to give me what? X1 y1 z1. So A is what? X1 I cap plus y1 k cap, y1 j cap plus z1 k cap. right everyone? Then I'm going to write plus lambda times ai cap plus bj cap plus ck cap, because that was what everyone? That was my b vector. This is my a vector, this is my b vector, and this is my r vector, right everyone? Yes. So xi cap, okay. Now basically what I'm going to do is everyone, I am going to send this vector, that is the a vector, to the other side. What I'm going to do everyone, I'm going to send this to the other side. Okay, even if I don't do that, that is also okay. But what I should observe from over here is that, let's observe something. So this is my x. So x will be equals to what? X will be equals to the coefficient of I on the right side, right? X is a coefficient of I cap on the left side. So over here, it should be also equal to the coefficient of I cap on the right side. So what is the coefficient of I cap on the right side? It is going to be x1 plus lambda times a, right everyone? So my x will be equals to x1 plus lambda times a. My y will be equals to x2 plus lambda x2 y1, okay, plus lambda times b, okay, and my z will be equals to z1 plus lambda times c. I will send this to the other side, so it will become x minus x1 upon a equals lambda, okay, right? I will find the value of lambda from this equation, right? Similarly over here I find the value of lambda from this equation. It will become y minus y1 upon lambda equals b. Over here I will do the same thing. Z minus z1 is equals to lambda, right everyone? Yes, b. God, what am I doing? Lambda. Yes. So basically everyone, these ratios are nothing but equal to the same quantity, that is lambda. So that's why I can write them equal to each other everyone. Yes. So this is nothing but Cartesian equation of a line. Is this clear everyone? Tell me yes or no. Any doubts till this point? Okay. So very important everyone. This is very, very important. This is Cartesian equation of a line. There will be a 5 marker, okay, in option to find the Cartesian and vector equation of a line passing through this point or through that point, or through that particular line that is it is parallel to. Okay. Now, what is the other way that you can find a unique line? What is the other way that you can write down a unique line? The other way that you can write down a unique line is when it is passing through 2 points. If the line, okay, see, think about it everyone. There can be a unique line that can be drawn from 2 points, right everyone? Yes, can you draw 2 lines from 2 points? No, right? So to draw a line, either you need 2 points or you need a point and the slope. Either of these things, right? So we have considered both the possibilities. I hope this is clear to you all. Yes, everyone? So now observe everyone. So what is going to happen over here, everyone? Let's say, for example, over here I have, oops, just a second. I have a line like this, okay? And it has 2 points. It is passing through 2 points, A and B, right? And both of them have a position vector, right, everyone? Yes. Now, this is my 2 points, everyone. If you will observe, you will find something out. Okay, so this is A vector and this is B vector, right? Yes, and the line is parallel to which vector, everyone? This vector is nothing but what? This vector is B minus A vector. Right, everyone? Yes. So this is parallel to B minus A vector. This line is nothing but parallel to B minus A vector, right? Yes. And it is also passing through the point A, right? Since it is passing through point A, so R vector is going to be equals to A vector, and it is parallel to B minus A vector, right? Because see, this is AB vector, it is parallel to, right? And AB vector is what? Position vector of the final and the minus the initial, that is B vector minus A vector. So it is going to be lambda times B vector minus A vector. There is a bigger proof as well, which will be more clear, but I don't think we have that time, everyone. We do not have that luxury, right? So it's just what, everyone? It is just a quick recap. Okay, so R vector is what? R vector is any other point on this line, right? Like this, right? This is my R vector, right? This is my point P. Okay, I hope it is pretty much clear to you all. Please tell me yes or no. Yes. Okay, so that is about it, everyone. Okay, so this is R vector equals A vector plus lambda times B minus A vector. So what will be the Cartesian equation of this particular thing? Now, remember everyone, it was x minus x1 upon A. For the one, when you had, it was parallel to one of them, okay? Right, B, and Z minus Z1 upon C equals lambda. But when it was B vector, when in the lambda, when lambda was being multiplied with B vector. Now lambda is being multiplied with B minus A, right? What is B, everyone? B is what? Chalo, let me write down. A is x1, I cap, we know that, y1, j cap, plus z1, k cap. What is B, everyone? B is x2 because it is another point on the line, right? y2, j cap, plus z2, k cap. What is going to be B minus A? B minus is going to be x2 minus x1. Okay, y2 minus y1 and z2 minus z1. So this is the Cartesian equation of a line passing through two different points. I hope it is clear to you all. Please tell me yes or no. Any doubts till this point, everyone? So this is important, everyone. Now there is shortest distance between two skew lines. What is the shortest distance between two skew lines? Okay, let's first understand this diagram. Okay, these are two skew lines, everyone. Okay, skew lines are what? Skew lines are those lines which are never going to meet each other, right? Yes. Now you must be thinking, sir, but lines, if they are not parallel, then they will meet. But in three-dimensional plane, two lines can neither be parallel and they will also not intersect each other. So you see, everyone? So those kind of lines are going to be what? Skew lines. Okay, so over here, you might think, sir, they will intersect, but no, they are not intersecting, right, everyone? Basically, this line L2 is going in another direction. It is going behind the screen. And let's say this is coming out of the screen like this. Let's imagine that way. Okay, everyone? So now, what is going to happen? So over here, everyone, what is this? These points, okay? This is the position vector of S, let it be A2, and position vector of T, let it be A1, right? And point P and point Q, that is going to be, now see this, let the line L2 be parallel to B2 and line L1 be parallel to B1 vector, right? Line L2 is parallel to B2 vector, line L1 is parallel to B1 vector, right? The position vector of S is A1, right? Position vector of T is A2, right? So basically, what is the formula? Shortest distance. Shortest distance, everyone, please observe. So shortest distance is B1 cross B2 dot product with A2 minus A1, A2 vector minus A1 vector upon magnitude of B1 cross B2. This is the vector formula, vector-based formula. But there could be the Cartesian formula, everyone. What is the Cartesian formula? The Cartesian formula is looking like this, everyone. The determinant of x2 minus x1, right? A2 minus A1. So x2 minus x1. Y2 minus Y1, Z2 minus Z1, right? Upon make cross product, everyone. This is cross product. So it is going to be cross product of B1, B2. That is going to be what? B1 is what? A, A2, A3, right? Yeah, sorry. B1, C1. Let this be A2, B2, C2, right? Upon minor of x2 minus x1. What is the minor of x2 minus x1? B1 C2 minus B2 C1. B1 C2 minus B2 C1 whole square. Because that will be the magnitude of B1 cross B2, right, everyone? Yes. the minor of A1, A2, basically the minor of Y2, Y2 minus Y1, right? So that is going to be how much, everyone? That is going to be A1 C2 minus A2 C1 whole square, right? Plus, basically, think you will be done with this formula only, right? I will teach you to solve problems in such a way that you will be done with this formula only, everyone. Okay. So what is it going to be? Plus A1 B2 minus A2 B1 whole square, right? Yes. So that is about it, everyone. This is the Cartesian. Okay. Because B1 stands for what? B1 is A1 I cap plus, B1 J cap plus C1 K cap. B2 is what? A2 I cap plus B2 J cap plus C2 K cap. Right, everyone? Important. Now, the last thing, finally, then we can move on to questions, everyone. Shortest distance between two parallel lines. Now, since we have only one parallel line over here, everyone, so they both are parallel to a vector B, right? And this S is what? The position, this point S has a position vector A1 and this point T has a position vector A2. And both of these lines, since they are parallel to each other, so there will be parallel to some B vector. So B cross A2 minus A1. A2 minus A1 is what, everyone? A2 minus A1 is nothing but the point through which both of these lines are passing, right, everyone? Okay, so it is going to be what? Upon magnitude of B vector, right? Yes, simple, everyone. Okay, over here my two lines are what? My two lines over here are nothing but line L1 is equals to what, everyone? Line L1 is equals, not equals, line L1 is R1 vector, R1 just, R vector is equals to A1 plus lambda times B1, right? Line 2 is equals to R vector, A2 vector plus lambda times B2 vector. So if you have lines, two lines looking like this, because this is a vector equation of two lines, right? So if you have a vector equation looking like this is the formula you will use. Okay, right? Is this clear, everyone? Yes. Same thing over here as everyone. So let's say, for example, you have two lines that are parallel. So line L1 will be what? Line L1 will be R vector equals A vector plus lambda times B vector, A1, right? Yes, because they're passing through different points, right? So the line 2 will be passing through different point, A2 vector plus lambda times B vector. But since they are parallel to the same vector B, because they are parallel, so they will be parallel to same vector B, right? Is this clear, everyone? So these two lines, that is how you will apply over here the formulas, okay? Taking the values of A1, A2 and B vector, okay? From the equation that is given to you, right, everyone? And one important thing, everyone, angle between two lines, right? So we will learn that as well, angle between two lines. So angle between two lines is going to be what, everyone? Is going to be cos theta is equals to what? Is equals to B1 dot B2 upon magnitude of B1 and magnitude of B2. Okay, so this is going to give you your angle between two lines where both of them, okay, both the lines, one line is parallel to B1 vector, another line is parallel to B2 vector. Okay, let's say, for example, you have two lines, everyone. Okay, line 1 is R vector equals A1 vector plus lambda times B1 vector. The second line is R vector equals A2 vector plus lambda times B2 vector. Okay, the angle between these two lines will be what? Cos theta is equals to B1 dot B2 upon B1, magnitude of B1 into magnitude of B2, right? So these are some important formulas, everyone, right? And this is your first question for the day, wherein they have asked you to do what? They have asked you to find the coordinates of the image of the point 1, 6, 3 with respect to R vector, okay? Where lambda is scalar. Also find the distance of the image from the y-axis, okay? Now see, this type of question, definitely it can come. See, there will be what? Let me tell you what, how is this going to happen. 5 marker is going to come, okay? And it will be an option. A 5 marker is going to come from vector and 3D, right? most probably it is going to be from 3D, where they will be asking you to, find the image of a point along a line, right? Find the shortest distance between two lines. That is another kind of question that can have come from over here. So these are the two type of questions that is going to be in one of the either choices in the exam, because this question will come in choice, right? It is going to be in one of the either choices. Okay, either it will be a shortest distance, or it will be find the reflection, or find the image of this particular point along a particular line, right? Definitely it is going to happen. Okay, right? Otherwise also we will see different type of questions that can come in the exam. So these are all PYQs, everyone. So try this question out, everyone. Come on. 3 and 2 markers will also come, but that will be most probably from vectors. Okay, it will be based on scalar product or dot product, and it will be a proving based question, which you will be able to solve very, very easily. Okay, and that also might come in option. So no worries in that. This is going to be the easiest chapter in your board exam. Jasim, Sachi, Nishad, please turn on your cameras. Everyone, fast, very easy question. Okay, let's do it, everyone. This is so slow. Rohit, where are you? How
Sir,
far away?
in the image,
Huh?
find the distance of
Okay.
image from y-axis.
Okay, go on fast. Rest of you, Ibrahim, Afan, what about you all? Huh? Jasim, Mehek, Nishad, Sachi, please turn on your cameras. टॉप बैचेस के बच्चे ऑन नहीं कर रहे कैमरा हाँ okay so I have one response sir there is a problem in my camera Jasim where is the answer have you sent it
No, sir, I was just doing it.
are you
But I'm
stuck
not sure how to. Yeah, I'm stuck. I'm not sure how to exactly do it. What
mm-hmm.
I did so far was I took the vector r, which is given,
Mm-hmm.
and the point 1, comma 6, comma 3, and
Mm-hmm.
I drew another vector parallel to r, so that the b vectors are equal.
Got it
And I found the perpendicular distance using the formula b cross a2 minus a1 divided by magnitude of b.
okay
And I got the distance as 13, but after that, I'm not sure how to find the image.
image is correct Rohit and the distance you have not given Rohit you're confused in distance Rohit tell me
Sir, doing.
Still doing it. Acha, distance will be from what point, Rohit? From where will you find the distance? What will be
Sir,
the point on y-axis through which you are going to find the distance of the image that is 1, comma 0, comma 7?
sir,
Hmm?
from
Not sure?
um,
Hmm?
I think it'll be 0, comma say y, comma 0.
0, comma 0, comma 0. You'll find the distance from the origin. So basically it will be root of 1 square plus 7 square, which will be root 50. Okay. Are you getting my point, Rohit?
Yes,
I'll
sir.
tell you the reason why. Okay. So please observe everyone. So this is my line, everyone. Whose vector equation is what, everyone? Whose vector equation is r vector is equals to j cap plus 2k cap. Everyone, please observe the screen. Rohika, please on the screen. Okay. If you have not been able to do till now, it is probable that, it's something new that you are going to learn. So please observe, right? Yes. So this is my thing, everyone. So this is my R vector, which is A, and this is my B vector, A vector and B vector. This is the point through which it is passing, and this is the point through which it is parallel, right? Yes, everyone. So basically, this line is parallel to what, everyone? It is parallel to another B vector, right? Which is going to look like this, I cap plus 2j cap plus 3k cap, right, everyone? And there is a point P 1, comma 6, comma 3, everyone, right? Yes. And I have to find its image. The image is always inside the mirror. See, consider this as a mirror, everyone. Observe, everyone. This line is acting as a plane mirror. And if you remember, you must have learned this in physics, everyone. What have you learned? Mehak, on the screen, beta, please, on the screen. Okay. You can do it afterwards. You can try it on your own afterwards. Okay. So the distance, this distance will be equal to this distance whenever the mirror is plane, right? This much physics that I remember, everyone. Yes. So now observe. So basically, if I try to draw a line that intersects my line, that my main line, okay, that is acting as a mirror, this point P, let it be A, and let this point be P, and let the image be point Q, everyone. Yes, everyone. Is this clear? Now, what will be my point A, everyone? What will be my point A? I know that this R vector is a position vector of any general point on this line, right? So from this particular thing, I can find out what, everyone? I can find out the point A in terms of lambda, right? So it is going to be what? This is 0 I cap plus lambda I. Okay, so my A, it is going to be lambda. Okay, the direction ratios of A is what I'm going to find. See, what is this, everyone? Let me remind you all if you do not remember. Okay, I do not understand how you all have given the J exam. ZK cap is equals to what, everyone? Is equals to 0 I cap plus 1 J cap plus 2 K cap, right? Plus lambda times I cap 2 J cap plus 3 K cap, right, everyone? Yes or no? So X key value will be what, everyone? 0 plus lambda times 1, right? So that is just lambda, right? Y key value will be what? 1 plus 2 lambda, 1 plus 2 lambda. Z key value will be what, everyone? It will be 2 plus lambda times 3, right? So 2 plus 3 lambda. Are you all satisfied that this is going to be my direction ratios of point A? Yes or no, everyone? Tell me. Is everyone satisfied how I have calculated the DRs of point A, of position vector A? Yes. Now, everyone. So I will write it over here. Lambda 1 plus 2 lambda, 2 plus 3 lambda. Okay, everyone. Now what I'm going to do. This is my PA, everyone. And my PA is going to be perpendicular to what? It is going to be perpendicular to this line. That means it is perpendicular to the line, to the vector to which this line is parallel. That is B vector. So keep that thing in mind, everyone. So what is going to happen? Observe. So I will first find out my PA vector. PA vector is what, everyone? Final minus initial. Position vector of A. Position vector of A is what? That is nothing but this, right? Minus the position vector of P, right, everyone? Yes. So it is going to be lambda minus 1 I cap. Okay. 1 plus 2 lambda minus 6, right? So that is going to be what, everyone? 2 lambda minus 5 J cap, right? 2 plus 3 lambda minus 3, right? So that is going to be how much, everyone? That is going to be 3 lambda minus 1 K cap, right? So this is my PA vector. Now, if I take the dot product of PA vector with B vector, what is going to happen? What is it going to be? It is going to be 0, null vector, because both of them are perpendicular to each other, everyone. Is this making sense to all of you? Please tell me yes or no. Yes. So that is why, everyone, once I do this, let's say, for example, over here, PA vector is lambda minus 1. So lambda minus 1 times 1 over here. You see over here, B vector, everyone. B vector, corresponding directional ratios of B and PA. So lambda minus 1 times PA. Lambda minus 1 times 1. So that is going to be lambda minus 1 times 1. 2 lambda minus 5 times 2. 3 lambda minus 1 times 3 is equals to 0. I hope it is pretty much clear to you all. Please tell me yes or no.
It was 2 lambda minus 5.
Sorry?
It was 2 lambda minus 5.
Oh, yeah, so sorry. 2 lambda minus 5. Thank you so much, Mehak. Okay, so it is going to be lambda minus 1 plus 4 lambda minus 10 plus 9 lambda minus 3, which is equals to 0, everyone, right? So what is it going to be, everyone? This is going to be lambda, 4 lambda, 9 lambda. That is going to be 14 lambda minus 1 minus 10 minus 3 minus 14. Minus 14 goes to the other side, which is 14. So lambda is equals to 1, everyone. Is this clear, all of you? Tell me yes or no. So I have my lambda, everyone. That means my point A is going to be what? My point A is going to be 1. 1 plus 2, 3, right? 2 plus 3, 5. So that is my point A, right? 1, 3, 5. 1, 3, 5. Now, remember, everyone, this distance and this distance is the same, right? Yes. Most of you, I think, must have used the distance formula, but there is a better approach. Let this Q be alpha, beta, gamma, right, everyone? So you can use the midpoint theorem, everyone. Alpha plus 1 upon 2, okay, right, comma, or not, will be equals to what? It will be equals to 1, right? Yes. Beta plus 6 upon 2 will be equals to what? Will be equals to 3, because this is my midpoint, everyone. This is my midpoint of Q and P, right? So that's why x1 plus x2 upon 2. Remember the formula of how we used to find midpoint. Alpha plus 1 upon 2 is equals to 1, right? Yes, beta plus 6 upon 2 is equals to 3. Similarly, gamma plus 3 is equals to upon 2 is equals to 5. This will give me alpha equals 1. This will give me beta is equals to 0. This will give me gamma is equals to 10 minus 3, 7. Okay, everyone? So gamma, we have the image of the point. Now that we have the image of the point, we must think to ourselves, what will be the point that will have the shortest distance with my image on the y-axis? 1, 0, 7. Acha, tell me everyone, on which plane is 1, 0, 7 going to lie? Which plane of the three-dimensional space? 3D Cartesian space. Tell me everyone. Huh?
Exact plane.
XZ plane, right? Yes. So let's say this is my 3D plane, everyone. Okay. This is X and this is Z and this is Y. So my point is going to lie on this plane, everyone. Right? Yes, this plane. Right? So if it is, let's say, somewhere over here, okay, 1, 7, and so it is going to be somewhere over here, right? On this plane, right? So the shortest distance will be with what? Will be the origin itself. Are you getting my point? Are you getting this, everyone? Tell me. Think about it intuitively, right? Because if I go to the y-axis like this, it is going to be a hypotenuse, right? If I go to y-axis like this, it is going to be a hypotenuse, which is going to be longer, everyone. Are you getting this or not? Please tell me, everyone, yes or no. Yes. So the shortest distance will be with the origin. That means if I find out the magnitude of this particular 1, 0, 7 itself, that will be what, everyone? That will be the shortest distance with the y-axis, because 0, 0, that is the origin itself, is also a point on the y-axis, right? So that is going to be what, everyone? If I try to find out, let's say, for example, this is my OQ. My OQ will be what? Will be I cap plus 7k cap, right? OQ magnitude will be root of 1 plus 7, 1 square plus 7 square, that is root of 50. I hope it is clear to you all. Please tell me yes or no. Any doubts on this question? Next question, everyone. An aeroplane is flying along the line r vector is equals to this, okay? And where lambda is a scalar, another aeroplane is flying on this particular line, okay, where mu is a scalar. At what points on this line should they reach so that the distance between them is the shortest? Find the shortest distance between them. Now over here, everyone, you can find the shortest distance between them directly using the formula, right? But you also have to find the points, right? Are you getting my point, everyone? You also have to find the points as well. So do it in a way where you find the points first, okay, and then you move on to the next thing, right? Yes, do not use the formula first. No, don't use the formula. First, find the points. What no, Sir Jasim? What did you say no? For what thing?
So you asked if there are any doubts, you just said no, sir.
Acha, okay.
That's it.
Okay, everyone, I'll be back in just a minute. Please try to solve this out. Okay, I'll be back. Rohit, camera. Ibrahim, camera. Rohika, camera. So shall we do it, everyone? Come on, tell me. Yes, Jasim and Rohit, how far away are you? Acha, Rohit has already sent. Rohit, what is this value? 1 is the distance between them. Huh?
1 unit is.
Okay, 1 is the distance between them. Okay, I don't know. Maybe it could be. I'll have to check that out. Okay, and Jasim, what about you? How far away are you? Am I pronouncing your name correctly? First of all, that is it Jasim or Jasim? Still, how
It's
long? How
Jasim
far
only.
away? Huh?
Sir, I'm not sure how long it's gonna take so far. Then
Chalo, let's observe everyone. Chalo then. Okay, observe everyone. Okay, Rohika, Ibrahim, Mehek, Nishad, Sachi, observe. Now, what are they saying, everyone? They're saying that an aeroplane is flying along this particular line, okay? And another aeroplane is flying along this particular line. At what points on the line should they reach so that the distance between them is the shortest? Right, everyone? Good job, Rohika. So now what is going to happen, everyone? We have one line. Okay, now acha, tell me, everyone, are these two lines parallel or skew, Rohika? Are these two lines parallel or skew?
There's skew.
Skew,
Skew.
because they are not same, right? Even they are not, a scalar multiple of each other, both of these vectors, right? Both of the B vectors, right? So it is going to be what? Let's say this one is I minus J plus K, right? It is parallel to this vector, right? Yes, let's call this B1 vector, right? Let's call this B2 vector, this be parallel to B2 vector, that is minus 2J cap plus K cap. Right, everyone? Yes. And there is a point P, okay, that and point Q. okay, on this particular line, that will be having the shortest distance. Now, distance is always perpendicular, everyone, right? The distance is always perpendicular. Is it not, everyone? Tell me yes or no. Yes. Okay. So what I'm going to do is, everyone, first I'm going to find the direction ratios of point P. Then I'm going to find the direction ratios of point Q. Okay. Then I will find the PQ vector. Then I will dot product it with P1 vector and equate it to 0. And the same PQ vector dot product with B2 will equate it to 0, right? Because they are perpendicular in nature, right? So that is the methodology, Jasim. Please observe, okay? Yes, on the screen. Yes. So now what is going to happen, everyone? We are going to find the direction ratios of point P. How are we going to do that? Very simple. We have been given that this is my R vector, right? So it is going to be what? It is going to be X is equals to lambda, right? Y is equals to minus lambda, right? And Z is equals to plus lambda again. Okay, so these are the direction ratios of point P in terms of lambda. Okay, everyone, what is the direction ratios of of the second line? So it is going to be 1 plus minus 2 mu. Okay, so 1 minus 2 mu. Okay, comma 1 minus 2 mu minus 1. No, gadbad. 1 only, 1, because there is no I cap over here, so it is just 1, right? Minus 1 minus 2 mu. Okay, minus 1 minus 2 mu. Right, everyone? Yes. And then 0 k cap, 0 k cap, right? Plus mu k cap. So it is just mu. Okay. So Z is equals to mu. Is this clear? Everyone tell me yes or no. Any doubts till this point? Yes? No? Great. Wonderful. Observe, everyone, further on. Okay, so I'm going to find my PQ vector, which is going to be what, everyone? Very simple. PQ vector is going to be 1 minus lambda. 1 minus lambda I cap. Right, everyone? Minus 1 minus 2 mu minus lambda. Right? Okay, minus lambda. So it is going to be minus 1 minus 2 mu minus, that is plus lambda, everyone. So it is going to be plus minus 1 minus 2 mu minus plus, that is plus lambda, everyone. Right? Yes. Okay. So that is J cap. Okay. Then for K cap, we will do this same thing. So mu minus lambda, right? So it is going to be mu minus lambda K cap. I hope this is clear to everyone, Please tell me. Yes. So this is my PQ. If I take the dot product of PQ with B1, it is going to be 0, everyone. Yes or no? Right? It is going to be 0 because it is perpendicular to that as well. Right? Shortest distance will be perpendicular to both the lines. Right? So now, what is going to happen now? So 1 minus lambda times 1. So 1 minus lambda times 1 plus minus 1 minus 2 lambda times minus 1. So that is going to be how much, everyone? That is going to be minus 1 multiplied by minus 1. That is going to be plus 1 minus 1 multiplied by minus 2 mu. That is going to be plus 2 mu. Okay. And it is going to be how much? Minus 1 multiplied by lambda minus lambda. 1 multiplied by mu minus lambda. So plus mu minus lambda, which is equals to 0. So minus lambda minus 3 lambda. 2 mu plus mu, 3 mu. 1 plus 1 plus 2 equals 0. Right, everyone? Same thing I will do to PQ vector dot product with B2 vector. Okay, which is going to be equals to 0, everyone. Okay. So what will I get? PQ dot B2. So it is going to be 1 minus lambda is multiplied by 0. So 0. Minus 1 minus 2 mu plus lambda multiplied by minus 2. So it is going to be minus 2 multiplied by minus 1 minus 2 mu and minus 2 lambda. I hope it is just plus lambda because minus 2 is still outside. Okay, then 1 multiplied by mu minus lambda plus 1 multiplied by mu minus lambda is equals to 0. I hope it is clear to you all. Please tell me everyone yes or no. Okay, minus 2 multiplied by minus 1, 2, okay, plus 4 mu minus 2 lambda plus mu minus lambda is equals to 0. Okay, so that is going to be how much, everyone? Plus 4 mu plus, that is going to be 5 mu minus 2 lambda minus lambda, that is going to be minus 3 lambda, and plus 2 as it is plus 2. So I have a pair of linear equation in two variables, equation number 1 and equation number 2. I'm going to use the elimination method on them. Everyone has turned their camera off. Wow, wow, wow. Just so cool. Sir को बोलने दो. Tell me, everyone. दीपक सर और सुमेर सर की क्लासेस में भी यही होता है 1202, 1202 and 1201. टेल मी. ऐसे ही करते हो? सर अलाउ कर देते हैं? सर कैन वी यूज the distance formula by vector method? Rohit, you can use that, but you can use that, but you will not be able to find points then, no? Are you getting my point, Rohit? Yes. Okay, this way you will be able to easily find out the points. I will show you how. Okay, please observe first of all. Right? So let's find out the value of lambda and mu. Okay, so I will just subtract equation number 1 from equation number 2. Right? So it is going to be how much, everyone? It is going to be 5 mu minus 3 mu. That is going to be 2 mu, 3 mu, 3 mu, 3 lambda cancel. And that is going to be 0. So mu is equals to 0. Mu is equals to 0. Mu is equals to 0. Okay, so mu is equals to 0, everyone. Okay, so I will put it in the first equation, right? So I will have 3 lambda minus 3 mu plus 2 equals 0. Okay, mu is equals to 0. So 3 lambda. नहीं, it is क्या कर रहा है आदित्य? क्वेश्चन कॉपी भी ढंग से नहीं करता. 3 mu minus 3 lambda plus 2 is equals to 0. Mu is equals to 0. So minus 3 lambda plus 2 is equals to 0. Right? Minus 3, that is going to be lambda is equals to 2 by 3. Right? So lambda and mu we have, everyone. We have the value of lambda and mu. We will be able to find out the direction ratios very easily. Right, everyone? Yes. So what will be my direction ratios, everyone? Let me write it down over here with the diagram so that you understand this. So point P will become what, everyone? Point P will become 2 by 3 minus 2 by 3 and 2 by 3. Okay, everyone? Yes, sir, I used the vector distance formula and didn't get the answer. You will get the answer. You must be doing some kind of an error. Okay, you will get the answer still, but this is the best method. Okay, because you have to find the points as well. So minus 1 minus 2 mu. So mu is equals to 0. So that is going to be 0. Okay, everyone, is this clear? Tell me yes or no. Any doubts till this point? Yes. So these are my points, everyone. This is my point P and this is my point Q. Okay. Now I will find PQ vector. Right? How will I find PQ vector? Position vector of Q minus position vector of P. Okay, or direction ratios of P minus direction ratios of Q. Okay, everyone. Yes, so let's do that. Right? Yes, so that is going to give me PQ vector is equals to 1 minus 2 by 3. 1 minus 2 by 3 I cap. Okay. And minus 1 minus 2 by 3. So plus 2 by 3. So minus 1 plus 2 by 3 J cap. 0 minus 2 by 3. So that is minus 2 by 3 K cap. Okay. Now what I will do is, everyone, I will find out PQ vector ka magnitude, right? 1 minus 2 by 3 is what? 3 minus 2, that is going to be 1 by 3. Minus 1 plus 2 by 3, that is minus 1 by 3, right? This is minus 2 by 3. So PQ vector ka magnitude is going to be root of 1 by 3 ka whole square plus minus 1 by 3 ka whole square plus minus 2 by 3 ka whole square. Right, everyone? So that is going to give me how much? That is going to give me 1 by 3 whole square. 3 square I can take common out. That is going to be 1 by 3 outside. Yes, I will have 1 square, that is just 1, plus 1 minus 1 ka square, that is just 1, and minus 2 ka square, that is just 4. Right, everyone? I hope it is pretty much clear to you all. Please tell me yes or no. Is this clear, everyone?
Yes, sir.
Yes,
Yes.
sir.
Any doubts? So that is going to be 1 by 3 root of 6, right? And basically root 2 by 3 units is your answer. Okay. I hope this is clear to you all. And let me check who got correct answer. Rohika has got the correct answer. Nice. Next question, everyone. Third, given A vector is equals to this. Equals, everyone. This is equals. A vector is equals to this. B vector is equals to this. C vector is equals to this. Find D vector such that it is perpendicular to both A and B. Okay. And C dot D is equals to 3, everyone. Okay. Try this out. You all will be able to solve this question because it's an easy one. Come on. Everyone, I want answer from everyone. Come on, this is easy, everyone. I want answers from everyone. Sir, can I leave because the electricity is about to be cut off for repair purpose? Okay, Rohit. Rest of you, please turn on your cameras, everyone. Jasim, Mehek, Ibrahim, Nishad, Sachi, camera, Sachi, Sachi. What is it? How do we pronounce it? Come on, easy question, everyone. Find the D vector. Vector you have to find, Jasim. To find vector, you do not have to find any value.
Oh my God, I just
You found out the value of the magnitude of the vector D. Is that what you got?
yes. No, not exactly. I got the constant lambda. I just said it.
Okay, you got the lambda. Okay. Shall we do it, everyone? Tell me. Hmm? Sir, is it? That's correct, Rohika. Good job. Amazing. What about the rest of you? Okay, one more response. No, Jasim. No. Mac, I've heard that you're one of the toppers. I'm not getting any responses from you. You're not doing this question.
No, so I just started doing it.
You started doing it.
So I got disconnected in the middle, so I
Ah.
started.
No worries, no worries. Chalo, observe everyone on the screen. Okay, what is going to happen? They are saying that A vector is this, B vector is this, and C vector is this. There is a D vector which is perpendicular to both A and B. Okay. If D is a vector that is perpendicular to both D, A and B, so D must be parallel to A cross B. Why, everyone? Why it should be parallel to A cross B? It should be parallel to A cross B because D is a vector which is perpendicular to both of them. A cross B gives a resultant vector which is perpendicular to both A and B. So D must be parallel to A cross B. So we can write, just simply observe, D vector is equals to lambda times A cross B, right? So what is going to happen? What is A cross B? So lambda times A cross B. Let's find out A cross B. So D vector is equals to lambda times the determinant of I, J, K. Okay, everyone. I is how much? That is 2, A cross B, right? So 2 minus 1 and plus 1, right? Yes. And B is how much? That is going to be 3, 0 and 1. I hope this is clear to you all. Please tell me, everyone, yes or no. 2 minus 1 and 1. 3, 0 and minus 1. Actually, this is minus 1, right? So that is going to be lambda times, now I will just calculate it. Okay. So lambda times minus 1 into minus 1 will become 0, everyone. Oh, sorry, will become 1, right? 1 minus, so that is going to be I cap, right? So that is going to be minus 2 minus 3. So that is going to be minus 5. And since this is J cap, cofactor of this 1, 2. So that is going to be plus 5 J cap, right? Then K cap, cofactor of K cap, that is going to be 0 into 2 minus minus 3, that is plus 3. So plus 3 K cap. Okay, so that is my D vector with multiplied with a scalar lambda. Now what are they saying? They are saying that C dot D is equals to 3. Right? So C dot D is equals to 3, everyone. What is C, everyone? C is nothing but 2I cap plus J cap minus 2K cap. So 2I cap plus J cap minus K cap, right? Minus 2K cap, sorry, minus 2K cap, right? Multiplied by dot product with with D vector. Okay, so lambda times I cap plus 5J cap plus 3K cap. Right? 2 multiplied by lambda times 1, so 2 lambda. 1 multiplied by lambda times 5, that is going to be plus 5 lambda. Okay, everyone. And minus 2 multiplied by that is going to be minus 6 lambda. So minus 6 lambda. C dot D, they gave us equals to 3. Right, everyone? I hope it is clear to you all. Please tell me yes or no. 2 plus 5, everyone, that is going to give me 7, and 7 lambda minus 1, that is going to 7 lambda minus 6 lambda, that is going to be lambda, and lambda is equals to 3. So I've got lambda that is equals to 3, everyone. So my D vector is going to be equals to what, everyone? My D vector is going to be 3 times I cap plus 5j cap plus 3k cap. Okay, everyone. So this is my D vector. Okay, everyone, one bonus question for you all. Okay, very beautiful question. Take a screenshot of this question. This is a PYQ. I think this is a PYQ or one of the questions in the sample papers of past year. Take a screenshot. We will do it in the next webinar or in the next class. I made a calculation mistake, sir. No worries. Okay. So I hope all of you have taken a screenshot over here. Okay, thank you so much. So that is going to be all for today. Had a great time interacting with you all, everyone. Bye-bye. Have a nice day. Thank you so much.